Now, look at the video. We'll discuss about the AVR microcontroller architecture. In Atmega 328 microcontroller, there are various components and peripherals available. It provides 32 kilobytes of on-chip in-system programmable flash memory. It is also called program memory, as it stores the program flash to the microcontroller. The memory has endurance at least 10,000 write and erase cycles. The flash memory is organized as 16K address of 16-bit length, as the AVR instructions are either 16-bit or 32-bit long. 14-bit program counter is used to address the flash memory. The flash memory is divided into the two sections, bootloader and applications program sections. The microcontroller also contains 1 kilobyte of EEPROM memory, that is electrical erasable programmable read-only memory, and is a type of non-volatile memory used in computer integrations in microcontroller and other electronics devices to store relatively small amount of data. It is organized as a separate data space in which single byte it can be read and write. EEPROM has endurances at least 1000 write or erase cycles. The microcontroller provides 2 kilobytes of SRAM. SRAM stands for the static random access memory. It is a volatile memory, meaning the data stored in SRAM is lost when power is removed. It is also called data memory as it is stored the data during program executions. Notice that the flash and SRAM are connected to the AVR CPU through different buses. This is the differentiating characteristics of Harvard architectures. The separate program in data bus enable the microcontroller to access the program and data memory independently and facilitate CPU pipelining. The next instructions while the current instructions is being executed. The clock generations module support various clock sources and can be configured by setting appropriate value in the clock select bit in use by. The microcontroller supports low power crystal oscillator, full swing crystal oscillator, low frequency crystal oscillator, and has two internal RC oscillator, and it can work with external clock too. The device is switched internal RC oscillators enabled and clock device by 8 fuse programs. The frequency of internal oscillator is 8 MHz and clock divided by 8. Result in microcontroller running at 1 MHz. There are 3 timer counter unit with compare mode and PWM. A real-time clock in the microcontroller. The timer 0 and timer 2 denoted by TC0 and TC2 respectively. There are 8-bit timer and TC1 is a 16-bit timer. It also provides a programmable watchdog timer with internal oscillator. Watchdog timer is used to recover the system from software failure by resetting the system. TC2 support asynchronous mode. It is operational in power save mode and allows use to maintain a timer while the rest of the device is sleeping. The microcontroller supports 3 serial communications protocols, mainly SPI, DWI, and USART. Peripheral interference SPI allows high-speed synchronous data transfer between the device and peripherals unit or between several AVR devices. The in-circuit program used to flash boot ladder and application use SPI protocol. The Universal Synchronous Asynchronous Serial Receiver Transmitter, this is called the USR, is higher flexible serial communications device. The USR also be used in the master SPI mode. It is commonly used to communicate with development PC. The two wires serial interface protocols, that is TWI, allows the system designer to connect up to 1028 different devices. The TWI is compatible with Philips I2C protocol. The microcontroller has 3 GPI input-output ports, which includes 23 input-output lines. The port B and D are 8-bit, while the general-purpose input-output is used to communicate with peripherals. The individual GPIO pins can be configured independently and have symmetric drive capabilities. That means the pin can source and sink same amount of current, and when configure has input-output, the microcontroller supports two external interrupts and 23 pins change interrupts. It also supports the interrupts from watchdog timer and other timer, USR, EEPROM, A to D converters and analog comparator. The microcontroller also provides analog comparators and analog to digital converter. The analog comparator compares the two voltage and set the analog comparator output accordingly. The comparator output can be set to trigger input capture functions of DC1. The analog to digital converter converts an analog input voltage to 10-bit digital value through successive approximations. The microcontroller supports 6 sleep modes. Sleep modes are used to save power by enabling the applications to set down unused modules in the microcontroller. The various sleep modes allows the user to tell the power consumptions according to the application's requirement. The power management of Atmega 328 supports brown-off detections. The BOD circuit monitor the supply voltage and reset the microcontroller with the supply voltage follows predefined threshold. The trigger level of the BOD is selected by BOD level bit and external value high bytes. The table shows the maximum power rating at Mega 328 microcontroller. The voltage on any pin except the reset pin must be in the range of minus 0.5 volt to VCC plus 0.5 volt with respect to the ground. The reset pin allows the applications of minus 0.5 volt to 13 volt and higher voltage is applied to reset the pin in high voltage programming mode to rescue the fuse. The maximum operating voltage of the microcontroller is 6 volt. The I/O pins can source and sinks 40 mA current. VCC and ground pin should not be supply current in excess of 200 mA. About 200 mA because of the excessive power, the microcontroller and development board will be damaged. These are the complete microcontroller architecture's explanation.